Hello everyone, welcome to Physics Pathfinder. In this week, we are going to concentrate on revision, and we'll have a revision series starting with Theme B. Today we are revising the content from B1 to B4. Here we'll be solving past paper questions from the subtopics B1 to B4. Let's start. Looking at the question here, you can have a look. We'll start first with the paper 1 questions. Okay, concentrating on paper 1, the first question. Identify the energy transferred from an ideal gas to the environment during an adiabatic process. Now, what is an adiabatic process? An adiabatic process is where the system is isolated, there is no energy transfer. So in the equation, Q is equal to delta U plus W. For an adiabatic process, the heat transfer is 0. So the answer for this question is nothing but B. Going to the next question. Two gases X and Y occupy two separate sealed containers. X has a density D and pressure P. The average translational speed for its atom is C. Gas Y has a density which is 0.25 times D and the pressure is 2P. Identify the average translational speed of atoms in gas Y in terms of C. So if I open the data booklet, you will find the equation. Pressure of an ideal gas is given as P is equal to 1 over 3 rho times average translational speed square. So in this equation, if you can see here, for the gas X and for gas Y, the density is D, and for gas Y, the density is 1/4 of D. 0.25 D is nothing but D by 4. The pressure of the gas X is P, the other is 2P. Identify the average translational energy, translational speed. So if I make C as the subject, the equation is nothing but square root of 3P by density. So if I see that the first case, if the average translational speed is C, for the new case of Y, it is nothing but, the new translational speed is nothing but 3 times the pressure is changing to 2P and the density is becoming 1/4, which means D by 4, where 4 will go on the top. So if I compare it in terms of C, what I would do is I will separate out 3P by D. This term is a separate term which is C, and what is left after that is 8. So what I'm getting is square root of 8 times C, which is nothing but 2 root 2. So the answer for the second question is C, which is 2 root 2. Come to the next question. Here we are given that the peak frequency emitted by a black body of radius r is f of p. Using Wien's law and Stephen Boltzmann's law, we are required to find the luminosity. So let's recollect the laws. The Stephen Boltzmann's law is nothing but L is equal to E sigma A T to the power 4, and Wien's law is lambda max is equal to 2.9 into 10 to the power minus 3 over T. And we know the special case that for black body emissivity is equal to 1. So I can write that luminosity is sigma A T to the power 4. Now, for a sphere, the surface area is nothing but 4 pi r square. And applying Wien's law, replacing T with lambda max, I can substitute T raised to 4 as 2.9 into 10 to the power minus 3 over lambda max, the whole raised to 4. And we know the wave equation that C is equal to F lambda. So lambda is nothing but C by F. So based on this condition, we have sigma 4 pi r square 2.9 into 10 to the power minus 3 over C down FP over the top, the whole raised to 4, which is nothing but the answer P. Going to the next question. The substance originally in liquid form is cooled. The substance is originally in a liquid form, is cooled until it begins to freeze. The table here refers to potential energy and kinetic energy of the substance during the change of state. So very important keywords. State how the row correctly identifies the energy stored when the substance freezes. So during the change of state, there is only making and breaking of bonds. So there is no change in temperature, that is, there is no change in kinetic energy, which gives us the option either A or B. And when you are cooling, you are withdrawing heat. So when you are withdrawing heat, there is a reduce of potential energy because the heat is removed, which means the option is B. So we will continue with the revision series. See you in the next video, where we will continue with the revision of B1 to B3 for paper 2, that is theory questions.